Graphing cube roots is the same as graphing square roots, except we don't have domain issues. What we get instead of is a point of inflection. So when you graph a cube root, it's going to look like this. So it's going to still have that same square root shape right here, but we're also going to be continuing it in the other direction as well, like that. And this little point right here, that is our point of inflection. So that's what we need to find. Okay? So that's our first goal. And it's the same thing we did to find the domain. You take the inside, and you set it equal to 0. That's it. So we take the inside, and we set it equal to 0. Take the inside, set it equal to 0. So it's not less than or equal to, it's actually equal, because we're looking for one point, a point of inflection. And so that's how we're going to graph it. You're going to put that point in the middle. And we're going to pick one point to the left, which should be -1, one point to the right, 1. 1 point to the left, -1, 1 point to the right. So I'm talking about the graph itself. If we're at 0 right here, 1 point to the left would be -1, 1 point to the right would be +1. And this one's -2. So 1 point to the left would be -3, and 1 point to the right would be -1. And those are the values you want to plug in each time when you're dealing with a cube root, basically any odd root. So let's bring it down. Let's just bring them all down. And then there we go. So we're going to plug in -1. So that's the cube root of -1. I don't need a parenthesis. Which is -1. Because cube roots, we get to include it. It's -1 times -1 times -1, which is -1. F of 0, that's 0. And then f of 1 is the cube root of 1, which is 1. And there's our 3 points. So let's graph them. So it's 0, 0, -1, -1, and 1, 1. And remember, your graph should look like that. So you want to put a kind of a curve that way, like we did with the root, and then a curve that way. And that's all we need for a rough graph of a cube root. Let's look at the next one. So we have f of -1, and that's -1 plus -1, which is -2. And then the 0 is -1, and then the 1 would be -1 plus 1, which is 0. Alright, and this again is our point of inflection, so that's the point that's going to change at. So -1, -2, we change the size. -1, -2, 0, -1, and 1, 0, right there. And then again, curve, curve, just like that. All right, last one. Let's plug them in. And so that's negative, negative, which is +1. And that's 0. And so that would be 1, so it's -1. And then we graph them. So -3, 1, -2, 0, and -1, 1. So negative 3, 1. Negative 2, 0. And negative 1, negative 1. So now if you look at it, it's not that same shape here where they're in the line in that direction and you go out and out. These are reversed because what's happened is it's flipped. So make sure you flip it. There's a negative here. So what's happening is instead of going in this direction, it's going in that direction. And instead of going in this direction, it's going in that direction. Because what's happening is this was negative. Here, let me draw it in red. This is what it would have normally looked like without the negative. So it would have done that. So all the negatives are turning positive. All the positives are turning negatives, and all the negatives are turning positive. So positives turn negative, negatives turn positive. It's flip-flopped. But the points themselves will tell you what to do. So try these three, hit pause, give them a shot. So you should have these as your point of inflection. So remember, it's when this equals 0. That's our point of inflection. And so we pick 1 point to the left, 1 point to the right, 1 point to the left, 1 point to the right, and so on. And now we can plug them in. So you should have these values, which would give us these graphs. So this one, if you notice again, it's the same idea. If you have minus 3, it shifts over 3, and that's our point of inflection. Point of inflection's at 0. Since it's negative, it doesn't go up, it goes down. And it doesn't go down, it goes up. And then this one is at 2, 3. So if you notice, it's the same idea. Our point of inflection would be 2, 3. And 0, 0, because there's nothing being added, no h, no k. And this would be 3, 0, because our h is negative 3 and our k is nothing. It's just like graphing our quadratics. Same exact shifting idea. Plus 3 minus 1. Thank you.